All right, today we're going to talk about solving linear equations by graphing. And we're going to have eventually 4 different ways to solve linear equations. Linear just means they're a straight line. So it could be straight line up, could be straight line down, just a straight line. And generally to solve a linear, this is called a system of equations. The way we're going to do that is we're going to graph them and see where they cross. So we want to find the point or points that make both of these equations true at the same time. So therefore, sometimes we call it a simultaneous system of equations. So what we're trying to do is find the one point that balances both these equations simultaneously. So it's a simultaneous system. So the way we're going to do it is we're going to graph it, and I'm going to put it in slope-intercept form. So I'm going to take this 2x plus 3y equal to -3. And I'm going to put it in slope-intercept form by taking 2x to the other side. So I'm going to bring the 2x over to this side. So I'm going to subtract 2x on both sides, and I get 3y equals -2x minus 3. Now I want to get y by itself, so I divide both sides by 3. Make sure you divide each term by 3. So, the x term gets divided by 3, and the constant term gets divided by 3. So I end up with y equals -2/3 x take away 1. All right, and that's my one equation. The other equation, let me write over here, is going to be 2x plus y, and that is going to equal -5. And again, I'm going to solve it for y. This one's a little bit easier. I just have to subtract 2x from both sides and end up with y equals -2x take away 5. So we're going to graph both these equations and see where they cross. Remember, this is, if it's a number, if you have a number in front of the x, that's the slopes. This is the slope. This is the y-intercept. The number in front of the x is a ratio of two numbers. So if it's just a number by itself, you can always put it over 1. So we're going to start at -5 on the y-axis. So this is the y-intercept. So on the y-axis, I'm going to go to 1, 2, 3, 4, 5. Put a big fat dot at -5 on the y-axis right there. And then from that point, I'm going to go to the slope. The slope is rise over run, so it's -2 on the top, +1 on the bottom. So from that point, I'm going to go down 2 and over 1. Put another dot there. And I've kind of run out of room going this way, so now I'm going to go reverse direction and go up 2 and over 1 to the left. And I'm going to repeat that, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, until I get across the whole graph. So there's the line for my second equation, 2x plus y equals -5. Every single point on that line will balance that equation. There's an infinite number of them. It goes forever, both directions. And all those points, the x, y coordinates, will make this equation true, or this equation up here true. All right, the other equation is -1, so I'm going to start at -1 on the y-axis. The y-intercept is -1. From there, I'm going to go down 2 and over 3. The slope is -2 over +3. So I go down 2 and over 1, 2, 3, another dot there. Down 2 over 3, another dot there. And there I run out of room. So now I'm going to go back. I'm going to go up 2 and over 3, up 2 and over 3, and again until I go across the entire graph. So I want to see your dots across the entire graph. The reason for that is it emphasizes what the slope is, and you get practice plotting the slope. So all these infinite number of points are going to balance our first equation, 2x plus 3y equals -3. Notice there's one point right here that balances both equations simultaneously at the same time. And the coordinates of that point right there are -3 on the x-axis, +1 on the y-axis. So this is x comma y. Of that point right there is -3 on the x, +1 on the y. So I should go back to the original equations right over here, and I should put in -3 for x and +1 for y. and see if that balances. And you just do that on your equation. You don't have to do it by hand. So I'm just going to go 2 times -3 plus 3 times 1. My calculator tells me that's -3, so that equation checks. Then I'm going to put it in the second equation. You got to check it in both equations. So that's going to be 2 times -3 plus 1, and that's -5. So both equations check, and you always have to, verify that both equations do check. So that point there is the simultaneous solution to both of those equations, linear equations. So the solution is -3, +1, or you might write x equals -3, y equals 1.